Hello, welcome back to Algebra. We're talking about the concept of direct variation. We've covered it extensively in the last lesson. We've drawn lots of pictures. We've done a couple of problems. And by now you should know that a direct variation relationship means when one variable goes up, the other variable also goes up. And there's a specific form to it that we've discussed. Now, in the last lesson, we did talk about the fact that there's a linear, a line relationship that goes through the origin here. And so the problems that we did in the last lesson were very cookie cutter, kind of along those lines. Now we're going to throw a couple of problems at you that might make you scratch your head and wonder, how are they really direct variation with respect to one another? And so let's just dive right into it. I'm going to do two problems actually that are going to look completely not like they're direct variation at all, but we have to talk about the details there for you to understand why they are written the way that they are. They're designed to trick you basically, and I don't want to trick you. I want to show you how to do things. So the first one is like this. If P is directly proportional, which is another way of saying varies directly as, but here we say P is directly proportional to the quantity R minus 2. Now that's weird, but if it's proportional to the quantity R minus 2, and P is equal to 20 when R is equal to 6, find, let's see, proportional to R minus 2, put a comma there, and P is equal to 20 when R is equal to 6, find P when R is equal to 12. Now this looks really weird at first because it does tell you that it varies directly, but the thing that it varies directly with is not just a variable, it's a variable minus a number. So that looks really quite weird the first time you look at it. The easiest way to think about it is that you can have a variable that's directly proportional or varies directly as another variable, or you can have a variable that varies proportional or directly as a term, as some other construct on the other side. But what it basically means is it follows the same form, right? The general form of all of these things is that y is equal to mx. These two variables are related directly to one another, very directly to one another, with m being the constant of proportionality. But in this case, the two variables, they are directly related, but there's this term here. So what does that mean? It means if P is directly proportional, if I just put R there, then what you would say is P is directly proportional to R. That's what you would say. If the problem was if P is directly proportional to R, blah, 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 this is what you would write down. But P is not directly proportional just to R.